in this particular video, we're going to go over primarily domain and range, but we're going to also review this second problem here that a lot of us had issues with. So the first problem, I'm going to try to cut to the chase, and just to kind of keep you posted here, this is off of homework 2.1 on Pearson. Remember that you have 2.2 due this Sunday, and you have to do up to number, I think it was part of 8 or part of 6. I think there was 6 problems. But again, if you have any issues, please come see me after school. Do not wait last minute. So let's begin. Here we're going to have to state the domain and range. And the other part of this actually said to determine whether or not it's a function. So let's blow through this. This one, anytime it's just single digits numbers, discrete numbers just to be exact, you just write it in braces and then you list all the x values you have. So with that being said, all your x values are part of your domain, all your y values are part of your range. And that's the way it is, no matter what kind of graphic organizer you have. In this case, it's really just a list of coordinates here. And so it's going to be 6, and the last one is 3, but you don't need to rewrite it, right? So you don't actually have to do that. If you're going to repeat the number, just leave it as is because you already have a 3 in there. And then you would do the same thing for the range, right? Do the braces, and then inside put only the y values without repeating them. Now the question is this relationship here a function? A relationship is a function if your x values really just don't repeat, right? And because we have 2 3s, really it's not a function. So what'll happen here is, remember when we did it this way, we have a 3, and that 3 has 2 arrows going into the output or the range, and in this case it goes to 1 and 14. And just to remind you that as a person, you can't really give money to 2 different people. It's not sustainable. It's not going to function. So in this case, this relationship is not a function. All right, let's move on to the more tedious problem. But really, I just want to break down what this problem is doing for you. It really is just a checkpoint for you to be able to understand how much can you be able to plug in and understand how these inputs give you a specific output when you put it into this x right here and essentially plug it into this function. So because of time, obviously, I'm not going to cover all of them. I'm going to cover D, E, and H. Those are the ones that gave people problems, and I'm going to try to do this as quickly as possible, again, just to keep the video short. Again, this is supposed to supplement in case you are a little behind, but if you really need that personalized help, please go to tutoring. Look out for those emails. So here we have f of negative x. When we did this in class, I mentioned that you want to be very, you want to have that etiquette, right? Just be consistent with the way you write things. It'll help you in the long run. So here we're writing f of negative x. This is going to tell me that I'm going to plug in negative x into the function, and wherever I see an x, it's going to be negative x now. So we square it plus 4 times negative x minus 4. Okay, so here real quick, again, anytime we square something, it's always going to be positive. So if there's a negative in the parentheses, when you square it, it's going to be positive. So really, just to speed up the process here, negative x squared, squared is really negative x times negative x. Negative x. So if this was a number, it'd be negative 3 times negative 3, negative 5 times negative 5. It doesn't matter. Negative times negative cancels out, so just worry about the x's. And in this particular case, x times x is x squared. So we'd have 4x squared. And then in this case, be careful. Anytime you have opposite signs, positive and a negative, they will become a negative when you multiply. So that's negative 4x minus 4. And we're done with this one, right? So really what this says is that f of negative x, when you plug that in, this is your resulting new function or output, right? We don't have just a number here because we didn't plug in just a number, right? We plugged in negative x. Okay, on to the next one. The next one, E, looks a little bit intimidating, but it actually is one of the easier ones. So just to keep it simple here, and so that you could see what's happening, let's just write f of x. So right now we're doing e. Let's just write f of x, but I'm purposely going to leave some space here. And I will put 4x squared plus 4x minus 4. So when you're really solving for e, it says negative f of x. So what you're really doing is just literally slapping a negative in the front. And what you do to one side, you got to do to the other. So really, if you want to find out what negative f of x is, you literally just distribute a negative to the right, or where your function is at. So that gives us negative 4x squared, right? And over here, it's going to be negative 4x. And then the last term is going to be positive 4x. So what it really does is it makes your positives negatives and your negatives positives. Now, I didn't draw one arrow, but I'll do it right now. It's this first term. 4x squared is in the front, but understand that it was positive to begin with. Last one, h. The one that's really a little tedious. But again, the process does not change. No matter what you're doing, A through H, it doesn't change. You just keep it consistent. This is 4x plus h squared plus 4x plus h minus 4. Okay? So I'm going to try to keep this short again. So I'm not really going to work this part out all the way. But just to give you a breakdown real quick of what's happening there. Remember, what you really have is x plus h times x plus h. And then you're doing the foiling. If you're having trouble with that, then just come after school because you're going to need to see another couple examples so that you really get that down. So anyways, just to let some magic happen here, if you foil all of that out, you end up with 4 times, just to give you a visual here, the foiling of that would have been x squared plus 2xh plus h squared, and then plus, oh, darn, all right. So then you continue plus, now we're distributing, we're in that middle term here, 4 times x is 4x plus 4h minus 4. Now we're not fully done here because this first term here, we need to distribute that, but we're almost there. And then as I write this out, I just got to remind you that at the end of the day, we need to combine like terms. So we take it back to algebra 1, really, when it comes down to combining like terms. So as I'm writing this out, I'm keeping an eye out for terms that have the same thing, right? H or xh or just x. So here we have x squared. Is there another x squared? Nope. Xh, is there another xh? Nope. H squared, is there another h squared? Nope, nothing to combine with. And if you look at the other three remaining terms, there's nothing to combine with anything. So really, this long little thing ends up being your answer. Okay, and that is the result of f of x plus h. Now, it makes sense that it's a little long. Look how many terms there were in there, right? And so when we have to do all this math, it ends up being a little lengthy. Cool. Now this is, again, I showed this, it's out of the realm of domain and range that we're focusing on for this section. But again, being able to evaluate any of these little ones is very important. So you'll get that down though, but we do definitely need some practice. So make sure you hop on Delta Math and get that done. So let's go ahead and do these last ones, right? These are, again, just strictly just finding a function's domain and range. This one actually just says find the domain. So we're going to stick to that. Please remember, there is a Delta Math already. Look at the last email and do some extra practice. But with that being said, let's go ahead and get started. To preface this, I recall that I gave you the parent function worksheet. If you do not remember the domain of the parent function, nor how the parent function looks like, etc., please take that sheet out and have it on top as you're doing this at all times, because you need to engrave those functions and their domain, those parent functions and their domain, into your head. All right, do not think that not knowing them off the top of your head is not going to help you in the long run. It's going to be crucial. So let's get started here. So find the domain. Remember, anytime we dealt with the, let me help you with this. Okay, let's start off with this basic one on the side. Let's say you had a function and it was x squared plus 4. So let's run through this verbally here. First of all, let me ask you, what is the parent function for this function here? All right, so you should say that in your head, and you should have said a quadratic. So remember what I said, a parent function for a quadratic, its domain is all real numbers, right? And remember, if this is the parent function, its child function here, right? Its transformation is going to basically have the same type of domain or a very similar one. So if the parent function's domain is restricted, so will this type of function. But in this case, what do we know about the parent function's domain? It's basically all real numbers, right? So in this particular case, you have a rational function to the left, okay? And here, just to give you the strategy, and we'll keep it like we did it in class here, is take the domain of the top first, right? And again, recall what kind of parent function this is. This is linear, and we know that a line, its domain is all real numbers, so even its transformation will have a domain of all real numbers. This one, some people wrote this down because I don't think I wrote it down for one of the classes, but this is a cubic function, and for those of you who have it down already, the cubic function's domain is all real numbers. So what is the domain of this cubic function? Well, all real numbers. Now, before, if we stopped here, the domain of this function would have been all real numbers, but there's one more thing we need to consider, and it's the fact that this function here is at the bottom. It's the denominator part. So denominator. What can we have in the denominator? 0. So in order to figure this out, what's going to give us 0 here, we need to set this function and say that we need to find that all x's that are going to give us 0, because we need to remove those x's from the domain. Okay, so now we're restricted for this entire function. So this is where it requires a little practice. Sometimes we don't know right away how to solve for the x's here without some notes and some practice. Here, when you have this type of situation, you actually want to factor out an x, because look at those two terms have an x, so factor one out. And then the next step is, once you do this is algebra 2 now, is you set each factor equal to 0, and we're almost done. So guess what, you already have one x value that you have to remove from the domain, because if you plug it in, check it out, if you plug in 0, what do you get? 0 cubed plus 7 times 0, that's 0. Can you have that? No, it's not allowed in the denominator. So you need to X this out, right? So as of now, our domain sits at all real numbers except 0. Now what about here? Can we figure this out? This is the situation where you want to try to do this in your head because it's a little easier. So is there a number that you can square so that when you add it, it gives you 0? In this case, you cannot, because you want to pick basically -7, because -7 plus 7 is 0. But nothing squared is going to give you a negative number. It's going to have to always be positive. So actually, just by checking that, this isn't really possible. So the only one we had to worry about is this one. So the answer to the top is basically all real numbers except 0. Okay. So basically, we always want to go from a negative infinity to infinity, but if there's a number we have to remove, we usually have to do this to it. It's the close the parentheses on the number we need to remove, union it, and then start back up at the number we have to remove, and then go to the next number if there was another one we had to remove, but in this case there isn't, so we just go up to infinity. Another way we write it in class is just like this. The domain is all real numbers except 0. Now, in class, we did not write this portion here. Usually this is necessary, but just to keep it simple for now until we really get good with domains, this is really what we've been talking about in class right here. So all real numbers except 0. But again, for those of you doing Pearson, this is actually what is necessary. You can't really get away with doing something else because Pearson is really picky about what you put in. All right, last one. What's the domain of the top? The domain of the top is just 4. So really, just for simplicity, we're going to say all real numbers, right? It's just 4. It's a line. The bottom, however, is restricted, so you must look at your parent function, and you realize that when you look at this, its domain is 0 to infinity, and just to keep it simple, it's because you can't have negatives in the radical. So we really can't do math with this, so really what you want to really see is, well, x greater than or equal to 0. These are both equivalent, so the domain being from 0 to infinity, including 0, because 0 can still go in the radical, instead of looking at it this way, we want to look at it that x basically can be any number that is 0 or greater than 0. So what you do is, because the parent function had this restriction, again, keep it the same. This isn't all real numbers, right? It's got a restriction. So really what you want to do is x minus 7 greater than or equal to 0. And that fixes that. So now, normally we would see all real numbers, but you just work it out. So you add 7 to both sides, and really what you get is x is greater than or equal to positive 7. So that's really your domain here. But again, we should be working with interval notation. So how do you write that as interval notation? So my x's are greater than or equal to 7. X greater than or equal to 7, think about that as being positive. So my smallest number that I could really get is 7. And that goes all the way up to infinity. And that's how you get that. But again, do delta math to practice so that you know how to write it like this. You know what I mean? So if it was just for the top, your domain would have been just all real numbers. But now that we did investigate at the bottom, this is really the most restricted. So this is going to be your domain for the function. But we're not done, right? Again, we're dealing with a fraction. So what do we need to consider? The fact that this is in the denominator. And this is where you're going to have to use your practice in order to make your life easier, right? In other words, we can't have that be 0 in the denominator. So really, if you want to do it the long way, again, you do it like before. Hey, what number is going to give me 0? But you should be able to eyeball this one, right? Really, x cannot be 7, right? Because if you plug in 7, 7 minus 7 is 0, and you cannot have that. So really, your domain is this, but now we have to exclude 7. But if you realize 7's already there, so how do we exclude just 7? Really, the solution is much more simple than we probably think at the moment. Really, it's the same thing, except now instead of it being a bracket to include 7, we literally put parentheses to exclude it. And that's your answer. It's really, the domain is really from 7 to infinity. Again, if you want to write it some other way, it would have been x is greater than 7, not greater than or equal to 7 anymore. Or, that's really what you need to know. So we'll keep it simple there. I hope this helped. Again, this isn't supposed to solve all your problems. This is supposed to help you if you really just were missing some pieces here and there. But if you really need help, please go to tutoring, and then we'll sort it out. I apologize for making this video longer than I wanted to, but it's really important that you get this domain stuff down, right? It's critical. It's going to be on your test, and it's half of your test. So again, watch this video, forward it, whatever. I hope it helps.